decreased pump efficiency, decreased discharge flow, and noises and vibrations, which eventually make it impossible to continue operating the pump. Impact pressure promotes corrosion and abrasion of the impeller, leading to shorter pump life. To prevent cavitation, raise the pump's suction pressure. In terms of pump operation, decrease the pump's discharge flow by reducing the discharge valve opening. To raise the suction pressure, decrease the suction line resistance. With some ships, suction line resistance is decreased by keeping valves on the suction line side fully open at all times. Their opening is not reduced. If a pump draws in air while in operation, a noise is produced, and the amount of seawater discharge decreases, significantly lowering the pump's operating efficiency. Also, the amount of seawater being discharged will drop to zero in an instant once the pump has drawn in a large amount of air. Why? When a small amount of air is drawn into the pump, the air passes out of the pump together with the seawater. But if a large amount of air has entered the pump, it gathers and gradually spreads to the pump periphery, decreasing the centrifugal force the seawater receives from the impeller and disabling the pump from discharging. If the discharge amount is extremely small, there are cases where unnoticeably small amounts of air gather within the pump and build up to a level that could disable the pump. If left as it is, seawater in the pump will run out, resulting in burn. Here you can see how air drawing occurs during discharge operation. In the beginning, the pump's pressure gauge reading is stable. Suction in the bell mouth area appears to be working smoothly. But now a vortex appears and sucks air in from the water surface, the beginning of the air drawing process. As the water's surface level lowers further, the water rapidly whirls around the bell mouth while rolling. This makes it easy for the pump to draw in a large amount of air. At this time, the pump's pressure gauge reading becomes unstable. As a corrective measure, reduce the pump's discharge valve. Then the gauge resumes stability. There are several ways to prevent air drawing. Purge air thoroughly before starting the pump. To deal with air drawing due to a suction vortex at the bell mouth, decrease the suction flow from the bell mouth by reducing the discharge valve opening to decrease the discharge amount. Note beforehand the water level at which the pump begins to draw air, and stand on the alert as the water approaches the critical level. You may use other tanks with a suitable water level to continue discharging. With some ships, cargo planning is based on the hull with trim by the stern. It's the suitable condition to discharge all the remaining ballast. If flow velocity within the pipeline suddenly changes due to valve operation at the start of or during pump operation, the pipeline internal pressure increases momentarily but sharply. This phenomenon is called water hammering. Water hammer can damage the pump casing, valves, and pipeline. Shown here is an experiment reproducing the process of how water hammer occurs. The apparatus used is an acrylic pipe fitted with a butterfly valve, through which pressurized water is passed. We observe the behavior of the U-tube attached to the pipe outlet. The acrylic pipe corresponds to the ship's pipeline. The U-tube corresponds to curved sections and pipeline dresser. The section of the acrylic pipe from the valve beyond is of negative internal pressure. In actual ballast operations, there are cases where cleaning with an eductor is carried out in the final stage, which calls for the ballast line pressure to be negative. This equipment simulates such a condition prone to accidents. First, let's look at a case in which the butterfly valve is fully opened suddenly. The U-tube is movable. When pushed by the water force, it moves back and absorbs the impact. With an actual pipeline, such impact cannot be absorbed fully, resulting in damages such as cracks. Damage to the dresser joint is typical. Now we'll review this process using an image simultaneously shot from 3 directions. Next, let's see the case in which the valve is opened slightly and stopped as is. No impact is placed on the U-tube. With the actual pipeline too, it can be understood that there will be no damage to the pipeline if you open the valve slightly and stop it as is. In ballast operations, attention should be paid to valve opening and closing. If a valve is abruptly opened or closed, it causes a sudden change in pressure within the pipeline. As a result, the valve can be damaged. Also, the dresser joint may break due to excessive load on it. The key to avoiding such troubles is to open or close valves slowly. It's also important to reduce the amount of flow in advance so that sudden pressure impact will not be placed on the pipeline. In addition, general points to remember for avoiding water hammer are as follows. Pay attention to the difference in pressures in both ends of the valve. Begin ballast operation with a small capacity and at a slow speed. And fill the ballast line with seawater and confirm that the line has positive pressure. Pressure surge is a factor of possible danger with valve opening and closing. It takes place when the flow velocity suddenly changes inside the pipeline, filled with fast-flowing water, due to abrupt opening or closing, whether remote or manual, of butterfly valves. In the event of a pressure surge, a high-pressure face propagates through the pipeline at a velocity faster than the speed of sound, causing damage to structural parts of the pipeline. So valves must be opened or closed slowly. With butterfly valves, since flow is not proportional to valve opening, remember that a large quantity of water may flow even if the valve opening is small. In short, open valves gradually by inching, stop when slightly open, and observe the state of things for a while. For valve closing, also do it gradually by inching. We can go so far as to say that most of the troubles associated with ballast operations can be avoided unless you open and close valves abruptly.